The question here is, could you do an example on classifying soil by the USE system? USE here stands for Unified Soil Classification System. So let me leave this chart here. The chart presents the guide for classifying a soil in accordance with the USE system. We talked about this in another video. This particular slide gives complete details on how to classify a coarse-grained soil. This slide presents the details on how to classify a fine-grained soil. So if you haven't seen the video on USE system, I recommend that you go back and view that first before you come and continue here. Here's the example that I want to do here. There are three different soils: soil X, soil Y, and soil Z. For each, we have the results of sieve analysis and values for the liquid limit and the plastic limit. Of course, the plasticity index is the difference between the liquid limit and plastic limit. We want to classify each of the three soils by the USE system. Let's start with soil Y. Here's a part of the chart. If 50% or more is retained on number 200, it's a coarse-grained soil, right? So going back to this column, we see only 5% of the soil passes through number 200, and therefore 95% is retained on that, right? And therefore this is definitely a coarse-grained soil. So the next thing we want to do is to figure out whether the soil is gravel or sand, and then further divide accordingly. So in order to do this, let's go ahead and find the percent fraction of each soil type. Remember, these are the dividing lines. The gravel to sand dividing line is 4.75 millimeters, which corresponds to number 4. And sand to silt dividing line is 0.075 millimeters, which corresponds to number 200, right? And from the table we see the percentage corresponding to number 4 is 97, and the percentage corresponding to number 200 is 5. So we have 97% for this and 5% for that. Therefore, the percentage of gravel in the soil is 100 minus 97, which is 3%. Percentage of sand is 97 minus 5, which is 92%. And the amount of fines in the soil is 5%. We are not given the grain size distribution curve for the fines, but what we are given is that the fines are supposed to be non-plastic. Alright, so whenever they say something like that, you know the fines is silt. Alright, so if it's clay, it would have been plastic. Alright, I brought our finding for soil Y from the earlier slide, so we can continue with the soil classification. Here is the rest of the chart. The next step is to decide whether the soil belongs to the gravel box or the sand box, right? The coarse fraction of the soil is the percentage of gravel and the percentage of sand, right? So that's 95% of the soil is coarse. Out of that, only 3% is retained on number 4, 92% passes, and therefore we definitely have sands. So at the next level, we want to decide whether we have sands with fines or sands with little or no fines. This is the criteria for doing that. We see that we have 5% fines in the soil, and therefore we have a borderline case. And therefore soil could be either here or here. Supposing say it's over here, right? And then we go down to the next level, we know that the fines is silt, and therefore it is not this, it is this, right? In other words, the label to be given for the soil would be SM. Sands with silt or silty sand. Over here I wrote down what we just discussed. Because we have a borderline case, soil could be one of these 4 types. But because the fines are silts, between these two, the soil is SM. Now we need to find out whether the soil is a well-graded sand or a poorly graded sand or both. So to proceed further, we need to go ahead and plot the grain size distribution curve, which I won't do here. I'll let you do that on your own. After you do, you go ahead and pick up values for D10, D30, and D60, and go ahead and calculate C sub U, the coefficient of uniformity, and C sub C, the coefficient of curvature. I used Microsoft Excel to plot my grain size distribution curve, And these are the values that I got for C sub U and C sub C. C sub U is 3.9, C sub C is 0.91. These are the criteria for the sand to be a well-graded sand. Cu must be greater than 4, C sub C must be between 1 and 3. And therefore, it's clear what we have is not a well-graded sand. It is a poorly graded sand. And therefore, between these two boxes, it belongs here, right? So, our final symbols are either SM or SP. So, we give a dual symbol, SP or SM. In other words, the soil is either a silty sand or a poorly graded sand. Now, let's go ahead and work on soil X and soil Z. So, now let's work on soil X. So, the percentage passing number 200 is 60. And therefore, this is definitely a fine-grained soil. So all we have to do is to take the values of the liquid limit and the plasticity index and plot a point in the Casagrande's plasticity chart. So when I did that, it plots right in this region, and therefore the soil is Cl to Ml. Now let's do soil Z. The percent passing number 200 is 97%. And therefore this is another fine-grained soil. So in the chart, the liquid limit goes only up to 100, whereas we have 124. So we just have to use the equation of the A line to locate this point. So the point actually plots above the A line, and therefore the label for this soil is CH. That's it. That's how you classify these three soils.